Yes, today I'm going to explain the polar NRZ. Okay, in that polar NRZ, it have the different types of NRZ NRZ levels. That is, one is NRZL and NRZI. What is the NRZI? I and NRZL. The non-return to zero level and non-return to zero inversion. The non-return to zero level, it contains the it contains the positive voltage for one symbol and negative for the another. Means like the positive voltage, like based on the usage we can use the positive voltage and the negative voltage. Here the inner ZL, okay, the level of the voltage determines the value of the bit. See, I am repeating, the level of the voltage determines the value of the bit. See, based on the usage, okay, we can take the we can take the values. See here initially, okay, I have told NRZ means it contains two values, that is positive and negative values. Okay, we supposed to implement these two value in the overall all the line coding method. Okay, here the NRZ schema I told, right, like if it is 1 it should be a positive, and if it is 0 it should be a negative. But why I am using here NRZL means a level voltage. Yeah, I can, like I told, it should be a positive voltage for one symbol and negative for the another. Like that I am, like based on the usage I have taken here a positive and negative. Here for like for the like this current time I am going to use 0, okay, I'm going to consider as a positive, and 1 I'm going to consider as a negative. Okay, like that I'm going to divide the voltages and I'm going to making use of the signals. Okay, I'm going to draw the signal. See here, 0, so this is the sequence of numbers. Okay, which way like we have taken, I have taken 0 1 0 0 triple 1 0. This is the digital data or a digital sequence. See, based on that I'm going to draw the signal diagram. See, if 0 have taken as a positive, 1. Okay, if you want you can take in negative also, no problem for this. Okay, based on usage I am going to taken. Okay, take here. See, if 0 have taken, see, high voltage, if it is 1 I'm going to consider as the negative voltage. Okay, I have draw the higher to lower. Again, if it is 0 is the positive, and if it is 0, yes, positive means higher voltage. If it is 1 1, okay, it should all will be negative. Again, if it is 0, yes, obviously the signal it is going to rise up. Okay, then what is NRZI? The NRZI is a non-written to non-written zero inversion. Here it is going to change, or the polarity should be change. It is going to determines the value of the symbol. Okay, until the one symbol, or until the first bit, it is going to it is going to inverse the polarity of the 0 or does not. Means, see, means until 1. Okay, when when the value 1 it become come. Okay, during that time it is going to taking the transition, or it is going to take the transition. Look, I'll show this here. See, 0 I have taken as a positive, right? If the same method I have applied in also in NRZ or L method also. If NRZI, 0 is positive, 1 is negative. See, yes, I'm passing the negative voltage here. Again, 0 means I'm telling, where till the next until the next bit 1. Okay, 1 it will occur, till that the value of the previous bit value will be remain same. See, if 1 is negative, again if 0, okay, you are rising, yes, 0 means you supposed to do the transaction will be high. Why you are not following that? Okay, why you are like applying the previous value? See, this is what the NRZ inverter technique. Okay, if it is 0, okay, yes, I cannot raise the signal up. Okay, means it should be follow the previous value. Again it should be 0. Yes, it is going to follow the previous result. Okay, that should be a low. Yes, if it is 1, yes, it is going to get started the transaction. Again if it is 1, yes, it is going to get the transaction here. Again if it is 1, yes, it is going to take the transaction. Yes, if it is 0, yes, the previous value will be remain same. Like that it is going to follow. So this method we call it as a NRZ inversion method. Okay, until the first bit, okay, until the next bit will be 1, it is going to taking the transition. Okay, otherwise it is going to follow the remaining like previous bit result only. See, this is what our NRZI. I am going to repeat once again. NRZI is, if it is 0, okay, I have taken a positive voltage. If it is 1, yes, it is a negative voltage. Again if it is 0, okay, I won't take positive, because the rules will be NRZI means if again the next bit will be 1, during that time only we have to take the like we have to take the transition. Mean, see, where the next bit will, from here it is going to take the transition. Until that, if it is 0 0, until that it is going to follow the value of the previous result. See, it is going to follow the previous value. The previous value is 1. Okay, then the remaining should be follow same thing. If it is 1, it is taking the transition. Again if it is 1, yes, it is taking the, if it is 1, it is taking the transmission. If it is 0, it is going to follow the previous value in the given time slot. See, this is what our NRZ. I hope, okay, like you have understood this concept. The next one is, what is polar RZ? The polar RZ is nothing but polar return to zero scheme, or is a polar return to zero line encoding. This polar return to zero, basically it contains three values, three voltage values. Okay, that will be positive voltage and negative voltage as well as the zero voltage. Okay, based on that, okay, we supposed to make the transition here. Then each symbol has a transition in the middle, either from the higher to 0 or from lower to 0. Okay, how, like we will see how it is going to happen from higher to 0 and lower to 0, with the help of using the three values of voltage, that it may be a positive, 0 and negative voltage. Okay, see, this is the sequence of the digital data or a binary value. Okay, see, if it is 0, I have taken the from lower level to higher level, from lower to higher in the RZ. Okay, then if it is 1, yes, it should be a higher to lower level. Okay, if it is 0, lower to higher. If it is 0, yes, lower to higher. If it is 1, yes, higher to lower. See, like that, like that the transition will be happen in RZ. I am going to repeat. If it is 0, it should be a lower to, okay, see, lower signal to higher. The signal, it is going to rise from lower to higher. If it is 1, the value will be 1. The signal, it is goes to like higher to lower. Again if it is 0, yes, lower to higher. If it is 0, yes, lower to higher. If it is 1, yeah, higher to lower. Like that we have to draw the digital signal. So this method we call it as a polar return to 0. Then in that polar return to 0, okay, I told it is a bypass method. Okay, it is going to use one of the special technique, that is bypass technique. In the bypass technique, okay, we discussed two types of line coding method, that is Manchester and differentiate Manchester. What is the difference between the Manchester and differentiate Manchester? Okay, we will see now. The Manchester, the line coding, it is going to consisting the combining the NRZL as well as the RZ schema. Okay, like it is a combinations of a non-return to 0 level and return to 0 zero method, okay, it that we call it as a Manchester technique. Here every symbol has the level transition in the middle from higher to low or lower